So please look at the current problem. You are asked to find the local maximum and local minimum values of the function f. And we can try to use the first derivative test again. So as a first step, you need to find the derivative f prime first. It is the same as 12x cubed plus 24x squared, right? And before drawing the sign table for f prime, we can actually set it 0. We need to find the critical number first. And I hope that you can do these on your own quite quickly. You can pick the common factor x squared out like this. So to solve this equation, I think it can be 0 or 12x plus 24 is 0. This one basically gives us the second critical number, which is minus 2. So this problem, there are actually two critical numbers. And from there, we can actually look at the sign table. So for the sign table of f prime, we noted before that there are actually two critical numbers. So I marked these 2 points here for the x-axis. And you need to randomly choose 3 points in the 3 intervals here and compute the f prime. We need to focus on the sign change of f prime. For example, the first interval here, you can pick maybe minus 3. Then you can compute f prime of minus 3, and similarly for the middle interval, you can use the point maybe minus 1. You can compute f prime of minus 1. And finally, for the last interval, you are actually free to choose any point bigger than 0. For example, you can choose 1. You can evaluate f prime of 1. So my computation is as follows. So please look at the calculations here. The first value is negative. The last two values are positive. So let's do the correct things on the sign table now. It's like minus, plus, and plus. And as a good habit, we can actually draw the tangent direction here. It's minus, positive, and positive, right? So now, what does it mean on this table? It actually means that based on this table, we note that there's only one point x equals minus 2 where there's a sign change for the f prime. You see there's a sign change only at one point, which is x equals minus 2. Is from negative to positive. Please look at this point, 0, the second critical number. There's no sign change at all. Both are positive. Both of the f prime are positive, so there's no sign change, which means that as a final conclusion, x equals minus 2 will get the local minimum because you see the sign change is from negative to positive, right? So for the f prime, and we have to evaluate the function f of x at this point minus 2. So this value is actually minus 15. It is the local minimum value for this function. And that's the end of this example.